Awesome. Okay, class, let's go with it. So we have 5.5. We're going to work on a few things here. So first things first is we have learned all these different formulas. In fact, I'll do it a little bit different. Remember the sum formulas we've learned so far, right? The double angle formulas we learned so far. Bless you. And the half angle formulas we learned so far. So what we're going to do is we're going to go just a little bit more deeper dive into the sum and difference formulas, the double angles, and the half angles maybe. We good? And then 5.5 is we're going to jump into here, sum to product. And if on the this is the bottom of your sheet, right? But if you go to the top of your sheet, there's the product to sum. We're going to handle these formulas today of 5.5. But before we get there, let's handle some weird situations with the sum and difference formulas, the double angle formulas. Whenever we did these before, we always talked about like real angles. Is that right? Like we added 30 degrees and 45 degrees, right? So what happens if these guys actually involve inverse trig functions? That's we got the first one in here. So we have inverse trig functions that are involved here. So notice it's sine of, and this technically, hold on real quick, you guys. If I take an inverse trig function, isn't this an angle? And isn't this an angle? So aren't these just two angles being added together? So if I set this guy to be sine of, and that would be my first angle called A, my second angle called B, isn't that just the sum formula for sine? So here's what I want to do. I want to be able to find the exact answer. So what happens here is when we use the sum formula for sine, we break it up into individual angles. And if I have individual angles, then I can get the exact values of these angles. And if I get the exact values of the angles, multiply them together, add them together, I will get the exact answer at the end. We good? That's what we want to do here. So I have this. I have angle A is equal to the sine inverse of 3/5. I'm going to make angle A. I know it's in quadrant 1 because the inverse function is positive. Over here, arc tangent. It's the same thing as tangent inverse, right? It's positive. Which quadrant am I in? 1. I'm also in 1. Yep. 4. For arc tangent, it can only be 1 or 4, right? If it's negative, right? So let's build our angles here real quick here. Angle A. Angle A is sine inverse of 3/5. I know I'm in quadrant 1. The angle looks like this. And I know that my y value is 3, my r value is 5. And what I do, I use the Pythagorean theorem to figure out my x value. And are we good with 4? Good there. That's a 4 there. Then we find our other angle called angle B. Angle B also is in quadrant 1 and is defined by tangent inverse to be 2. But yeah, technically you can do 2 over 1, right? So that means my y value is 2, my x value is 1. So therefore I label 2 and 1. And I again use the Pythagorean theorem to figure out the r value. So 1 squared is 1, 2 squared is 4, and 1 plus 4 is 5, and the square root of 5 stays square root of 5. That is my r value. So here we go then. Because we know the addition formula or the sum formula for sine, I just do individual angles themselves. So what's the sine of A? Y value, is that right? Over R value, which is 3/5. And remember, sine inverse and sine, they would cancel each other out if we're in quadrant 1, right? That's why it's the same. Because you're taking the sine value of the sine inverse value. Cosine. Cosine of B is, we go over here and we look for my x value over R value, 1 over root 5. And then cosine of A, and then we go back to the first angle and we look for x value over R value. Are we good there so far? And then we go back to angle B. Now figure out the y value over the R value. And then we multiply them together. And then we add them together. And then you know what? We're done. There it is. Okay, that was super fast because we did it already. Right? Can you guys do the next one? Yes, we can. On your mark, get set, go. Example 2. Here it is. Can you evaluate this one? Oh, cosine this time. Okay. Yeah, and then if we have time, we'll finish up the video that we started last Wednesday. Remember that one? It says my computer's working out. All right. And then again, as you guys go for it here. So let's see, tangent inverse of 1/2, right? I'll let you guys do that. And I'm going to walk around the classroom and you guys just tell me if you're stuck. Okay? I want to help you guys as you guys look at example number 1 if you need to, but if you're just stuck. All right. So we have not been a little bit. So you're stuck for that. Basically, that's it's 2 triangles. We list on that. You can label this one as A for that. Also, we could just do it's just like British social to go back to this one. Yeah, those are 2. And then also, if you can, from the formula sheet that you don't have, can you write down the sum formula for cosine? Because that's what the formula is going to be. So. Here, gotta do it. Yeah, I bet you big boss. There's about. So remember, we're with the sum formula, we are breaking it down into angles, individual angles, so we get exact values, right? And so let me walk around. You guys tell me as we go. Like Kirk said, I don't know. It's like, or do I don't want to, so maybe it's wishful thinking, but yeah, I think I do. I think you have to spit down. All right, yes, and please talk with the person next to you. Tell me what you guys get as we go here. This one just like that one. Isn't kind of weird, guys, when we learn something new, when we see someone else do it, it looks like easy, and then we do it, it's a little bit more difficult. I would agree with that. Right. Do this one. Okay, so tangent formula, that's our cosine formula, right? I'm going to just start a little bit here, pieces here. So I'm going to do the cosine formula for this guy. So this would be angle A is tangent of this guy. Angle B is this one. Right, everybody got those, right? Separated. And then the cosine formula that we need is A plus B is cosine A, cosine B. Subtract. Perfect. Yeah, so we need that. And now let's build our triangle. Let's see if we got to this part. Building our triangle, we are in quadrant 1. So tangent says y over r. So that means I got y is this one, x is this one. So I got a 1 and a 2. What is r value? 5. Go 5. Yeah, perfecto. So we're going to use the r Pythagorean theorem again, just like we did on the last one here. 1 plus 4 is 5, and the square root of 5 is square root of 5. Da, 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 da. So I got that one built out good. I'll need this guy for this angle. Is that right? I'll need it for this one. Okay, now let's build out angle B. Angle B is sine inverse of 1/2. So that means that's y over r. So that means y value is 1. R value is 2. What is the x value? Root 3 is perfect. Yep. So we don't know what x is. Y is 1, r is 2. It makes a 1 plus, or x squared plus 1 is equal to 4. Subtract 1 from 4, you get a 3. We are in quadrant 1, so we get radical 3. That guy goes there. We're good there. Okay, based upon that information, now can you do that? I was lazy. I didn't write out. It's so much for you. Instead of at least making sense. Shut up. No, okay, gotcha. Just came all 3. Okay. I'll let you guys copy that down, and if you guys are working through it still, go for it. Let me write down the answer if you have it. Let me write down the answer front board as you guys are still working through it. First time. Here's what I got. And see if you can work toward this here. This. I put 1 on the padding with 3, which is different. Final answer, if you guys are working through it here, I got some people who are working together. I'll wait just a little bit here. That's who's finally decided.
I'm just mentally lazy. I don't want to do all the out.
No, and
So there's an alley.
myself.
Exactly. Like that one pass that Lamar Jackson threw and caught himself. It's funny.
What? Oh, yeah, Jenna. Wait. Yeah, there was. I did that.
Plugging. Got you. Okay, so we start off there. So we would do is we designate the tangent inverse of 1/2 as our angle A. And then the other one we can designate as just angle B. So notice it's like cosine of one angle plus another angle. And so then we go back to our notes and that's the cosine.
That's really easy.
Addition formula for cosine. Right? Does that make sense? Does that make sense?
So that when
We're gonna build.
first of all, what do you think they would have?
We need pieces from triangle A.
What would they have?
And then we do is we go over here, we build triangle build.
Like what would they have to like remind like what historical segments would they have?
Sine of angle A is.
All the chickens.
What I'm just like, what will they have as a angle A?
It's gonna be what, are you looking at? Is that what you're looking at now?
Will it
So
still
so this one for angle A, cosine would be x value.
You can't like use one of sets anymore.
And then for cosine B, it would be here.
Yeah, like will they be able to access that? Or will it be like all that? It's just
Because you can get it now.
All right, still working through it here. Raise your hand if you got the answer that's on the board. Cool, okay, a little, oh yeah, over half the class here, a little bit, go for it. Give you just a little bit more time with it.
what will they be wrong?
Yeah, I think we can say. So you put in the true functions in your heart, because what you've done, so cosine of angle A is that value. Back here.
Is it we? Is Taylor the sine? So you know, actually.
This is why. That's not someone, the same as why.
Oh, wow. Oh, so.
X.
Oh,
That's when we had to build this, because we're missing the part.
okay, so. Oh, right, X, so the cosine is.
Cosine.
Yeah, cosine A.
Not the level of the ocean.
No, we're almost there. Water. So
But they don't, I
you're
don't
looking
think
at
they
cosine
drink
A,
it.
right?
Like,
It's the way.
Freshwater fish drink
Cosine
it,
by
but
definition is
saltwater
x
fish.
value over r.
Wait, why?
Maybe
That
so
doesn't
they
make sense.
And then actually wild.
Oh yeah. They both drink it, but saltwater fish don't pee because the salt in the water dehydrates them. They both drink one.
Why do you know
No,
that?
two.
It's the kind of thing you would
Over.
Yeah, but where do you know it
So
from?
it
Like,
just
is it a credible source?
a science video that my little sister was watching was probably.
Yeah. Like
I just walked by and heard it and I was like, shoot, saltwater fish don't pee.
they don't? Well, because what do they drink? Do they drink it through their gills or their mouth?
Yeah.
That's what I thought. I didn't think fish drank water. Because they like are water.
Like, eat, like, we don't drink air.
Breathe water.
Just farms.
I think they get the oxygen, they get the, but do they drink it through their?
But the fish are getting the stuff from the
They
water.
drink it through their mouth.
But nutrients from the water?
Yeah, they were just like.
Yes, I agree with Carrie.
That's what I thought, because they like are water, so aren't they automatically hydrated? Because they live in it and they're like breathing it all the time.
So they're always hydrated. I do.
Yeah, but then what's the point of drinking water?
She's like.
I think they drink through the
First angle, angle.
Oh, I thought that
and breathe.
I don't think they drink water.
Really, because we don't drink air.
Yeah, exactly. Well, but they don't drink air either. They
You know,
Absorb.
fish drink.
they absorb it through their gills.
I know that freshwater.
No, because fish like our water.
I imagine that. They have, but they live in water.
They live because the only reason to drink water is like hydration,
That'd be 2,
Yeah.
3.
and they live in the water, so then they don't.
Okay.
So then they don't have
I
to
think
drink.
they're also like significantly less water than we are. So like fish are kind of all water. They're a little weird.
Yeah, fish. Yeah.
And then.
I love speaking.
But they're not
Hey, class.
completely.
Awesome.
There's like
I
stuff.
think I got everybody good here now, right?
Bones and fish and.
So here's what I got. You guys tell me if you guys agree.
Like.
I think they get it from work.
So are we good here with this one here? I think everybody got the answer on the top here. I was just helping the people that, just to finish up here. So notice over here, you have a 2 on the bottom, 2 on top. It's almost tempting to reduce the 2's, but don't, because you still have the subtraction to do on the other side. And then
Where did the twos come from?
2's, yeah. So, yeah, let's go back. Thank you so much for the question. Uh-huh. Oh yeah, absolutely. So cosine of A, right? We're looking at angle A, and we're looking for cosine value. So it's going to be the x value
Oh.
over the r value.
Yeah.
Good. Okay.
Yeah, never
Perfect.
mind.
Good question.
That's crazy.
So I get this. I think everybody else is done. Is that right? We get ourselves. Tell me if you have any questions on that one. Are we good?
I just
Why
want
we
to
do
know
that?
guys, why these are low. I just need to know that.
Uh-huh. Oh yeah, especially for these. Uh-huh. Okay. Number 3, a little bit tricky. It's not going to involve addition or subtraction. It's going to involve maybe double angle formula and maybe a half angle. I'm not sure. We good? But you guys check it out to see which ones you think it is. There it is. I need to find this.
My little treasures.
Oh, wow. And there's not even numbers here. It's actually just X. So let's think about this here just for a bit. What is that? So think to yourself here, does that look like a sum formula? Does that look like a double angle formula? Does that look like a half angle formula? What does that look like? Okay, so what you can do, second, Ava says double. I agree with her. So now what you can do, so what you guys can do is that, see that tangent inverse of X? Normally, what do we use for angles? We use capital letters for angles, is that right? And sometimes you use theta, right? So if you just change that tangent inverse of X, let's make it like an angle, like let's say angle A. We good? So notice this guy, we're going to change just to angle A. So notice what this is going to say. It's going to say sine of 2A. Does that look like something on your notes somewhere?
Uh-huh.
Yes, that is the double angle formula for sine. And what does it equal?
2 sine A cosine.
Perfect. It's 2 sine of A cosine A. Are we good there? So we need to figure out, based upon this tangent inverse, what would be the cosine, or what would be the sine of this angle, and what would be the cosine of this angle? Are we good there? What do we have to build? We're going to build a triangle. That's right. So angle A is going to be given as tangent inverse of X. Oof. Adrian, come on in. So real quick here, so notice that little 2 here. Adrian, this for you real quick. So the question is, no, we're no longer adding 2 inverse functions. We actually are multiplying this tangent by 2. And if we make this into an A value, because we use A and B, we use theta for angles, right? If we just say, look, that's going to be an angle called A for now. And what happens is this becomes 2A, which is some kind of formula you should see on your notes. This is the double angle formula on your notes. Perfecto. So here's the thing. We can't just double angles, right? Because we don't know what the angle is even. But we can convert it back to single angles. And that's our formula that converts it back to a single angle. Now, if inverse tangent of A is X, you guys agree X is X over 1? Is that true? And what's the definition for tangent? It's Y, careful here, it's Y over X. So kind of careful, this is where things get confusing. Your x value, right, is your y coordinate. Are we good? And then 1 is your x coordinate. Are we good? So kind of careful here as you build this. This is angle A. My y coordinate is an x value, which is x. And if you want to, you can convert these to a's and b's if you like. But here's kind of what you got. A squared plus b squared equals c squared, or r squared. So notice this guy is x squared. This guy is 1 squared is equal to whatever r is going to be, right? R is our missing link, is that right? So if I have r squared here, I'm going to try to solve for this. X squared is just x squared. 1 squared is just 1. Are we agreed there? And all we're going to do is we're going to take the square root of both sides. And that's going to be our r value. Are we good? Again, no numbers, just values. So this guy is the square root of x squared plus 1. That's the value for r. So by definition, what's the sine of a? What's the sine of a over here? What's my y value? X over. Perfect. Megan, question? Because we don't know what the x value is, right?
Can you just say X?
Yeah, why is you worried?
They're adding.
We have to use. Then it'll be, yeah. Yeah, but we have to use the Pythagorean theorem, right? And Pythagorean theorem has a plus between the two, right?
If you squared that whole thing, what would it look like to get rid of the square root?
Oh, it'd just be x squared plus 1. Yeah, you would undo. Squaring undoes the square roots.
Oh, no, okay. Never
All
mind.
right, and what's the cosine of this?
Chainsaw?
Okay.
It's probably a chainsaw.
High chainsaw. Yeah.
Like through the middle of the.
All right, and anybody
Does it? Okay.
tell me what the final answer is? Anybody got this? 2x on top. Perfect. Yes. So notice, yeah, you have 2 square roots of the same thing, and if you add them together, they'll just give you that thing. So the answer to this one is 2x over x squared plus 1. This is kind of crazy, guys. We've created a formula that if we know what the value is, and we're trying to take the trig tangent inverse of it, and we double the angle there that's given, and we take the sine value of it, we can go directly to the solution set to it, which is this one. So if I had a 5 in here, right, I can just plug in a 5 into here and here, right? Okay, class, that is it. Let's see where we're at here. Whoa, we're out of time. We're practically out of time here. So let's do this here. I'm going to just,
Do math all day.
let's formulate.
It's weird.
That took longer than I thought. That's okay. So we are not going to be done with 5-5. But let's do this one here. Let's kind of just go to part 2. Part 2 is these guys called the sum to product formulas and product to sum formulas. And we've seen these before.
Part 2? Is that not what we just did?
No, that was just part 1.
Is this not what we just?
No, we just did inverse functions. Let's do this here. We'll build it on Wednesday, but let's build this right now. Class, do you guys recognize this formula? This formula is called the
Addition formulas.
addition formula for sine. So here it is. Here's what we got here, guys. We have Ptolemy sitting on a Saturday morning. What's happening outside?
Raining.
It's raining. He has nothing else to do except for math. And he says to himself, this would be interesting. What happens if I take the sum formula for sine
Oh.
and then I take the difference formula for sine? Anybody give me the difference formula for sine?
Sine A cosine B minus cosine A sine B.
I don't think.
Okay, sine of A, cosine B, right? And then the only change is this sign in the middle. Is that right? So he just says, okay, what happens if I take the difference formula between these guys? And what happens if I add them together? That's the craziness about Ptolemy. What happens on the left side?
Just becomes just 2 cosine B.
2. Sine of A, cosine B. Interesting. The middle's, oh, that little whole middle cancels. Is that right? And I'm left with what's going to happen here. It's going to be sine of A plus B. Perfecto. Cool. And then he wants to solve for this right over here. He wants to solve for sine A cosine B. What should we do?
Divide by 2.
Divide by 2. Okay, so then he gets totally excited. It's before breakfast. But he just figured out how to convert trig functions here from a product, which means two things multiplying each other, we good? To two things that are now just being added to each other. And that was it. Like, whoa, that was so cool.
Bake up olive bread.
A good amount of trig, yeah.
It's not real.
We're in a matrix anyway, so it's fine.
I think this is cool.
So we will do this one. There's only 2 problems, so we'll handle this real quick here, and then we'll handle the homework questions. We're good.
I'm ready.
With that, we are done for the day.
I said it before breakfast. This is true. All right, hold on. Okay, I have